Today we're talking about graphing linear equations in slope-intercept form. But before we start, we're going to do a little review of slope. So slope is the rate of change between any 2 points on a line, and slope is a measure of a line's steepness. To calculate slope, we look at any non-vertical line and find 2 points passing through that line. We call the coordinates of that first point x sub 1, comma y sub 1. And the coordinates of that second point are going to be x sub 2, comma y sub 2. And we find the ratio of the rise, the change in those y values, compared to the run, the change in the x values. And that it makes up our slope. So slope is sometimes abbreviated as m. We also call it the rise over the run, or the change in y over the change in x. Or, since it's the difference in the y coordinates, we can use this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So when I have a graph, I find 2 points that line passes through. I decide which point is going to be called point 1 and point 2. When I find the difference in their y values, I'm finding the rise. When I'm finding the difference in their x values, I'm finding the run. And the rise compared to the run, that ratio, is our slope. Another key concept when it comes to slope is being able to look at lines and tell whether their slopes will be positive or negative or zero or undefined. So if the line rises going from left to right, like that one over there, we have a positive slope. If the line falls as we go from left to right, we're going to have a negative slope. But if it's a flat line, if it's horizontal, we're going to have a slope of 0. A lot of times for our ratio, we get 0 over 6 or 0 over 8 or 0 over negative 4. All of those equal 0, a slope of 0, and result in a horizontal line. A vertical line has an undefined slope. These would be ratios that come out to be things like 6 over 0, 8 over 0, negative 4 over 0. We know we can't have a value divided by 0. There is no number for that, so it's an undefined slope. So let's talk about actually finding the slope given a graph. So on this graph, I see that there are 2 points, negative 4, comma 3, and 1, comma 1. It doesn't matter which point I'm going to call point 1, and which one I'm going to call point 2, but I have to decide. So I'm going to say this guy is going to be my point 1, and this one is going to be point 2. So now I'm going to use my formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my y for coordinate 2 is 3, minus my y for coordinate 1 is 1. So I get 2 for my rise. Now I'll do the same thing with my x's. The x for coordinate 2, for point 2, is negative 4. And my x for point 1 is 1, which gives me negative 5. So my slope is 2 over negative 5, or negative 2/5. And I would have known it was going to have a negative slope by looking at it because it's falling from left to right. I can also find slope when I'm looking at a table. Here I'm just given more information than I need. I have 3 points, 2, comma 10, 4, comma 15, 8, comma 30. So I'm just going to pick this one to be my point 1 and this one to be my point 2. So this one's just extra information. So my formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to follow my formula. The y for coordinate 2 is 15, minus the y for coordinate 1 is 10, gives me a rise of 5. And I'm going to do the same thing with my x's. The x for point 2 is 4, and the x for point 1 is 2. So for my slope, I get 5 over 2. So a couple more vocabulary here. So we talked about that slope-intercept form. Slope-intercept form is when we take a linear equation and we write it in the form y equals mx plus b, where m stands for the slope of our line and b is the y-intercept. A constant function is a linear equation written in the form y equals 0 times x plus b. Or, simplified, it's just y equals b. The graph of a constant function always results in a horizontal line. So let's talk about finding some slopes and y-intercepts by looking at these different equations for linear equations. So our first one here is y equals 3x minus 4. So we want it to be in the form y equals mx plus b. So all I need to do to change this guy is make it an addition problem. So I'll add and I get negative 4. So my slope here is in the place of where the m goes. So my slope is 3. My y-intercept is negative 4. For this problem here, I only have y equals 6.5. So the only explanation for where the x went is that it was multiplied by 0. So I can add it back in. So my slope here is 0, and my y-intercept is 6.5. If I were to graph this one, it would result in a horizontal line. All right, once again, I need to get in the form of that y equals mx plus b. So on this one, I'm actually going to add a y to each side. So I'm going to have negative 5x equals y plus negative 2. Then I'm going to add a 2 to each side. So I end up with negative 5x plus 2 equals y. If I really want it in the form y equals mx plus b, I can just take this equals y and flip it to the other side. So now for my slope, I have negative 5, and for my y-intercept, I have 2. All right, so let's say we're given a problem to graph like this one. It says graph 2x plus y equals 2, identify the x-intercept. Well, the first thing we want to do is rewrite our equation in slope-intercept form. So in order to do this problem, I'm starting off with 2x plus y equals 2. I'm going to subtract 2x from each side. So I end up with y equals negative 2x plus 2. I'm now written in that form, y equals mx plus b. The next thing I want to do is identify the slope and the y-intercept. The slope here is negative 2, and the y-intercept is at 2. So I'm going to plot the y-intercept. When I have my y-intercept and it's 2, that means it crosses the y-axis at 2. So here is my y-intercept. It's at 0, 2. Now I'm going to use my slope to find a second point on this line. So the slope is negative 2, or I can write it as negative 2 over 1. And this is like directions. Remember, this is my rise and my run. So I'm going to rise negative 2. So I'm going to go down 2, and my run is positive 1. So I'm going to go over 1. Here's another point. Down 2, over 1, have another point. Enough that I can connect them and make a line, and I can see that my x-intercept here is at 1, 0. Or I can just say the x-intercept is 1. All right, one more problem for today. We have a linear function called g, and it models a relationship in which the dependent variable increases 3 units for every 1 unit that the independent variable increases. They want us to graph g when g input 0 equals 3, and then identify the slope, the y-intercept, and the x-intercept. Well, first of all, we can figure out the slope from the information they've given us. The dependent variable is always our output, or our y values. So our y values are changing by 3 each time. So 3 is the equivalent of our rise. The independent variable is represented by our inputs or our x values. So if the independent variables are changing by 1, this becomes our run. So our slope is actually 3/1 or just 3. We also were given an input of 0 gives us an output of 3. So we have a point that we can actually graph. 0, 3. It's actually our y-intercept. So we've actually already found the y-intercept. Now we can use the slope to find other points on this graph. So we could go up 3, but our graph doesn't have very much space, and over 1. I can kind of estimate where that's going to be. But I could also do the exact opposite here. I can go down 3 and back 1. I could go down 3 and back 1. So I found my slope, it was 3. I found my y-intercept, it was 3 also. And now I've also found my x-intercept. If I look at my graph, it's crossing the x-axis at -1. So my x-intercept is -1.